Okay, Precalculus, here we go at Chapter 3. There are only going to be 3 sections that we're going to do for Chapter 3 because it's got some modeling behavior in it, and just with us having to slow down for reviews and tests, we're maybe going to skip some things along the way, and they're not as important, so here we go. Section 1 today, Section 3 tomorrow, Section 5, whenever the next day is Wednesday maybe, and we might be reviewing and testing by Friday on just these little 3 review sections, so we can really get into Chapter 4 here and start doing some solid work on polynomials. Okay, here we go. A linear function. You're going to feel that this is a pretty solid review kind of material stuff here. Linear function has the form f of x equals mx plus b. That is y-intercept form. You should be very familiar with it. So watch how easy this is. Graph the functions f of x equals negative 3x plus 7 and f of x equals 2/3 x minus 4. Okay, so that's the y-intercept. So I go up to where x is 0, and I put a point up where y would be 7. That's 0.07. And then the slope works like this. Every time I go over 1, I go down 3. So I go over 1 and down 3, over 1 and down 3, over 1 and down 3. Put a couple of points, and that is good enough for me to be able to graph my line. Probably don't need a ruler, just giving an overall feel for this. You've done this a million times. Negative 4 is my y-intercept, so I go down 4 and I put a point. The slope is 2/3, so technically what that means is when I go over 1, I only go up 2/3. I don't even go up a whole point. Go over another one, go another 2/3. But how we put points is we go up 2 and over 3, which is how you remember that. Up, rise over run, right? Rise, 2, run, 3. So I go up 2 and I go over 3. I go up 2 and I go over 3, and I have enough points to make my graph. But I do want you to know that the interpretation of slope, which we will talk about at the end of the show here, the interpretation of slope is as you go over 1, slope is how far you go up or down. So for this one, go over 1, go down 3. Go over 1, go down 3. This one, go over 1, go up 2/3. Go over 1, go up 2/3. For the function above, the first function above, so that's this one, y equals negative 3x plus 7. Find the average rate of change for the following sets of points. I'm going to go with f of 0 and f of 2. We did average rate of change last section. Here, I'll just draw little lines in here, making little areas in my paper. F of 1 and f of 4. And then also f of negative 3 and f of 5. Okay, to find average rate of change, you need x's and y's. And so, let's see, I was told f of 0, so I'm going to put 0 into the function negative 3 times 0 plus 7. I'm also going to find f of 2, which would be negative 3 times 2 plus 7. Well, this one's really easy to do. Anything times 0 is 0, and when I add 7, I get 7. Negative 3 times 2 is negative 6, and when I add 7, I get 1. So I have 2 points here, 0, 7, which I used to make the graph, by the way, and 2, 1, which I also used to make the graph. The average rate of change goes like this, the change in y over the change in x. And so you have to stay consistent. If I go with this one first for the y, 7 minus 1, then I have to go with this one first for the x and go 0 minus 2. That is 6 over negative 2. The average rate of change between those 2 points on the graph, 0, 7, and 2, 1, that average rate of change is negative 3. For f of 1 and f of 4, okay, f of 1 equals negative 3 times 1 plus 7, and f of 4 is equal to negative 3 times 4 plus 7. Negative 3 times 1 is negative 3, and when I add 7, I get 4. Negative 3 times 4 is negative 12, and when I add 7, I get negative 5, I believe. And so I have 2 points, 1, 4, and 4, negative 5. Average rate of change is subtracting the y's over the x's, so, and stay consistent with which one goes first. So I'm going to go 4 first minus negative 5 over 1 first minus 4. 4 minus negative 5 is like plus a positive 5, that's a 9. 1 minus 4 is negative 3. I get negative 3 again. For the point 1, 4 and the point 4, negative 5, the average rate of change is negative 3. I think you could guess what's about to happen with this third set, but we'll do it anyway. f of negative 3 would be negative 3 for the slope times negative 3 plus 7. And then f of 5 would be negative 3 times 5, and then plus 7. Okay, that's a positive 9, and 9 plus 7 is 16. That's a negative 8. Negative 8 plus, sorry, it's not a negative 8, that's a negative 15. And negative 15 plus 7 is negative 8. I'm just getting a little ahead of myself there. So I have the point negative 3, 16, and I also have the point 5, negative 8. The rate of change, the average rate of change is the change in y's over the change in x's. So when I go 16 minus negative 8, I'm going to get a big positive number. And I have negative 3 minus 5. 16 minus negative 8 is like 16 plus 8, so that's going to be 24. Negative 3 minus 5 is negative 8, and when I divide those, I get negative 3. Again, is anybody surprised that the average rate of change between any 2 points on this line, all of them are negative 3? No, you shouldn't be, because you've done this before. You've seen lines before. You know that lines have a constant rate of change. And you even know what we call it. We call it the slope. So let's go. The slope for a linear function is equal to the change in y over the change in x. That's equal to f of x sub 2 minus f of x sub 1. Those are two y values, aren't they? Over x sub 2 minus x sub 1. We also like to prefer to write that as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And sometimes people like to call it rise over run. That's how you find slope. It is the constant rate of change because lines don't curve. They act the same the entire time. An example with some words to it. Here's a set of data for the maximum number of heartbeats that a healthy person should have at different ages. Find several rates of change. So here's what I want you to do. Find the rate of change between those two and between these 2 points, and then we'll go with this point again and this last one. So use these 2 points and find the slope, use these 2 points and find the slope, and then use the 50 and 70, those 2 points, and find the slope. Do that now.